Hi folks, we're going to take a look at number 8 from the Unit 4 review. So here we have a balloon that's hovering 80 meters above a lake, and there's a man in a boat moving in a straight line and spots the balloon and measures the angle of elevation to the balloon. Okay, so let's say here, starter diagram, got our balloon up in the air, okay, and somewhere down here, 80 meters below on the lake, all right, we've got a boat that measures an angle of elevation to the balloon of 65 degrees. Okay. Now it says here that 25 seconds later, he measures the angle of elevation at 25 degrees. Okay. Now one of the assumptions we're going to make is that it's just traveling in that direction here. Okay. We're not going to create a sort of a 3D diagram here. We'll assume that it's a 2D diagram. The question is he moving in this direction or that direction? Okay. If you're moving in this direction, then the angle of elevation, we see that this angle would end up being larger. Okay, so if the second angle of elevation is 25 degrees, it means he must be moving in that direction. Okay, so let's draw his second position, and this is 25 degrees. Okay, and we want to determine the speed of the boat. So how do we determine speed? Now, again, we're going to make an assumption that he's traveling at a constant speed, so we need to find the distance traveled in the time that it takes. We already have the time it takes, 25 seconds, so what we have to do is measure this distance. Okay, once we have that distance, we can determine the speed of the boat. Okay, so this is our task at hand. Now, there is a condition. Here it says you may only use a primary trig ratio once. Okay, you could actually solve this without using sine or cosine law, because here I have enough information in this right angle triangle to determine that distance. And then we see that I've got another right angle triangle formed with the second position, so I could measure the total distance, and then I could just subtract. Okay, but they give us this condition that we can only use primary trig ratio once. All right, so that means that at some point we're going to have to work with this triangle here, which is not a right triangle, in order to determine this distance d. Okay, but we don't have enough information. Let's see what information we do have in this triangle. We have this angle 25 degrees. This angle 65 is not in the triangle, but I can easily use that to find a second angle in the triangle. So 180 minus 65, so from 70 to 80, so what do we've got here? We've got 115 degrees. All right, so 60, 70, two fives give me 80, so that's good. And I can find the third angle since I know the other two. So here 115 plus 25 is 140, subtract that from 180, so we've got an angle of 40 degrees there. So we have all the angles in the triangle. What we're missing is a side length. Okay, but remember, we are able to use this primary trig ratio once. So what I can do is use either this smaller right angle triangle to determine that length there, which is the hypotenuse in that triangle, or I can work with this larger triangle to determine the hypotenuse of that right angle triangle, which is also one of the side lengths in that triangle there. So I'll work with this small one here. So I'll call that x. And so I have the angle, I know the opposite, I'm looking for the hypotenuse, so I'm going to use sine. So we have sine of 65 degrees is equal to the opposite, which is 80, over the hypotenuse, which I called x. Okay, in order to solve this, I'm going to multiply x to the other side, and I'm going to divide sine 65 to the right side. So if you need to do this in two steps, you should. So I'm first of all multiplying that by x, and then I'm dividing by sine 65. All right, like I said, if you need to do that in two steps, I would strongly recommend that you do to ensure you don't make a mistake. All right, and so now let's calculate that. So let's get our trusty calculator. Okay, so what do we have? We have 80 divided by sine 65, and that's 88.27. All right, so now we've used up our primary trig ratio, can't use that again. So now I'm going to have to work with this non-right triangle. And because I have a side length and its opposite angle, I can use the sine law. All right, so I'm looking for d here. So I'm looking for a distance. So I'm going to use the version that has the lengths in the numerator. So I have d over the sine of its opposite angle, which is 40. Okay, equal to, now my known side is 88.27 over the sine of its opposite angle, which is the one I know, sine 25. And so now this is a pretty easy thing to solve for. I just multiply the other side by sine 40. So I have 8827 times sine 40 all over sine 25. All right, and let's calculate that here. So I already have the 88.27, so we'll multiply that by sine 40, and then we'll divide that by sine 25. Okay, and we end up with 134.26. All right, but this is not what we're looking for. This is just the distance. What we're looking for is the speed of the boat. And of course, the speed is given by the distance divided by the time, which is 134.26 divided by the time, which is 25 seconds. So here, this is equal to, already have it on the calculator, so let's just divide by 25, and we have 5.37. And that was in meters, and time was in seconds, so don't forget your units, meters per second. All right. So step number one was to get the diagram, all right, to realize that the further I am away from an object, the smaller the angle of elevation is going to be. So that's why I drew it in this way here. And because I was able to only use a primary trigger ratio once, I had to figure out how to work with this non-right triangle. Okay, that's it for this one.